Hello everybody, my name is Dr. Fahid Gerusi and I'm going to present some of our latest work in the context of a collaboration between my company, Bahar Software Engineering and Testunium Corporation in Turkey. We have been working on practices and tools towards next level of test automation. And what I'm going to present today is essentially an open source tool called GaugeDepend. Perhaps you have heard about a BDD tool called Gauge, which has been the next in the series of different tools after Cucumber and Gherkin. I won't go too much into the detail of what Gauge is, but I think I can give you some examples of what it is. So this is one of our papers which was published last year with this title, and I will provide the reference below this video. So yes, we published some of our work that we have been using the Gauge framework since 2008 in this particular paper, and in one of the sections we provide essentially how Gauge works. Essentially, test engineer writes some Gauge test suite, and this is an example of that. So here we are testing a web application called Testunium, and I will also show it in a few minutes. In the login page, do the controls for the email field, for the password field. So you write, so this is essentially high level of abstraction for your test code. And then you incrementally go to lower level. You break it into functions, the so-called test steps and test concepts. And here, for example, you have login using two particular username and password. So then you go down and the function, you write the code for it. You say inside the field email of login, write email, and inside the field password, write password, and check if the button sign in of login element exists, and then you click on that. So this is script called the other one, and then you also need to implement this in Selenium because it's a web application. So you say that for this step, what has to be done? So you enter a number of steps, so that inside the field key, and these are parameters, so you write a specific thing. So with that, again, as I mentioned, so this will be considered a test suite, and this is a test specification file which has some test scenarios. And so we have like one test scenario, and then it calls two test concepts. These are the test concepts, and each concept can have one or more test steps. So for example, this test concept has 3 steps, and the second one has 4 steps. So again, that's the concept as a meta model, and then you implement them in Java or in your language. And then the Gauge engines, well, this we call the Gauge engine, and Gauge engine will call your system under test. That's kind of how it works. So we have applied this to several systems with Testunium Corporation, and essentially during the many years of doing this, we found that when essentially while the Gauge framework is a powerful BDD testing tool, our experience has shown that especially when multiple test engineers are involved in developing large test suites, those test suites could often start to become unorganized, complex, and messy, and also internal quality of the test code will go down. This observation has also been observed by many other test engineers, such as this one that we are citing here. He mentioned that Mr. Carl Seguin mentioned a blog post that complex and messy tests don't add any value if the code under test is perfectly designed. So again, these discussions have been discussed in many other places. What we did, we used the concept of dependency analysis, which is a widely used technique, as you know, in software engineering, to show the dependencies of essentially test suites between the test artifacts. So this is a Python tool that we have developed. We call it GaugeDepend. well, I should change the title here, should be GaugeDepend. So what you give, you provide some test suite to it. And I already have some test suites here that we are testing, that we have written large amounts of Gauge suites. So essentially what I have here, we are testing a system called Selenium, and we have got a large number of specification and concept files, CPT and spec files. Even I will be glad to show you the system under test, which again is a very popular test automation management control tool called Selenium. Essentially, this tool lets you to write Selenium, a large number of Selenium test cases and test scenarios, and then schedule their executions and see their results. So it's like a web interface to Selenium. For example, here you can see that I've got, for example, several projects, and we can see their test results, etc. For example, again, these are a certain number of tests. You can see projects, you can see your scenarios, and you can essentially check their execution progress, and if they are in pass or fail. For example, this test suite take about 26 minutes. You can see more details. So because of this, by the way, one of the issues that we have been observing has been test smells. Yes. So they could suffer from test smells. Again, for our audience, test smells have been testers in the community have discussed test smells for many years. And if you go to Google and put test smells, you will see a huge number of hits. For example, there's even a website called testsmells.org. Unit testing smells. You can have it in GUI testing level, in test management scope, and even there are little like brochures or diagrams like this. I found this on a website. I think, yes, yeah, it's actually from a book on X-unit and test patterns. And the author has put them as like a tree. Project test smells, developers not writing tests. And there was also another paper that I was involved in a few years ago. So what we know about the smells in test software test code with two other colleagues. And we provided a huge catalog classification of test smells, more than 150 types of test smells. Some of the most commonly observed smells in practice are duplicate test code, long and obscure test, eager test, fragile test, and their explanations. So to address all of this, what we did, we developed kind of a visualization tool that you pass a folder of your test suites in Gauge, and you press parse folder, and then you can select. So then this one will automatically show up, and then you will select any part of this, any number of things that you want to visualize, and then you say draw graph. It uses kind of a graph API to draw this. So what you have here, we have got, I think, 1, 2, 3 spec files. Yeah, I can make it 4, and some concept files as well. Again, the details, these are some internal representation or file types of the Gauge framework. So here you have, for example, login systematic expect, and it says that it has this many test scenarios. These are some numbers that have been written in the test suite. Actually, you can go here and can even see them. For example, login systematic. You can go there and you can open them with Notepad. So these are some actual test scripts that have been written here. We use this representation again, as explained in our papers, to do a system of test cases. But now my goal is to see whether there are any issues in my test code in terms of test code architecture and design, and whether there are test smells. So, for example, I think a login one is a good one. Login system. For example, there is invalid login, valid login. This number 02 means the number of incoming nodes, and there are a number of outgoing nodes. So there are one outgoing node. And for example, you can see certain things are called a lot of times. You can go here. For them, it has been called 26 times because the line going through it's quite thick. So you can observe this, and if there are any kind of abnormality in terms of dependency, you can notice that. We also have written some initial work on detecting test smells, automated inspection. So if you click this, it will actually highlight in red the test smells that it has found. So now it's going to find some test smells. You can move the mouse. It says unused concept. What it means is that it says 02. It means that you have written some like a function. Let's go back to regular programming, and that function is not being called by anybody else. So that would be quite strange, right? Because you want your functions to be, you write the function in the first place so that it's called by somebody and it's used. So you have, in terms of test concept, again, that's the Gauge terminology. If it's unused and uncalled, means that, well, nobody's using it. So what's the point of writing it in the first place? So it's kind of, let's say, it's almost like a dead code, unused code. So there are quite a number of these things which something has to be done about them. The rest, some of them are okay. Yeah, the same one for this. For example, this one has been called at least once, so it's used. So this means that, you know, the test engineers who worked on it, perhaps, I mean, usually this happens because more than one person, a large team of test engineers work on the same project, and so they have written, somebody has written some test functions and nobody's using them. So it's essentially some refactoring and modification has to take place. Even you can say generate test smell report. If you click on, so 22 of the smells, the unused concept smells have been found. You can bring this, and it will actually show you that part of the diagram that those things are taking shape. It will actually, so you can go down and you can see all of them. Also, again, in the literature, there is the notion of long tests. So, I mean, we put the threshold to 10 steps, but I mean, that can be changed to higher value. So there were 2 tests which were really large. For example, check that the variable element is visible. This has 11 steps. Again, it's up to us to consider this as a long test or not, but that's another good feature that can be used. So this was, as I said, a short demo of our tool. Still, we are working on this tool and it's ongoing. Again, it's open source and it has been written in Python, and it has got quite a good, nice software architecture itself and design, so it can be extended by other developers. It's graph renderer models. Here it generates the data and then passes the graph renderer. The whole code is open source. We provide it on GitHub. Again, this has been a very good joint work between myself and folks from Testunium, and also one of my previous students called Connor Boyle, who did a very good groundwork for this work. And again, as I said, this work is ongoing. We are now adding, coming up with a new version called GaugeDepend Extend. So we are extending it, and that will also include, as you can see, this is just between test code. Then we will add some layers on the right-hand side, so that which parts of the system are called from by the test code. So that we are putting 2 or 3 more layers on the right-hand side, because these things, the Selenium codes, are calling the client-side code, the front end of the web application under test. Then the front end will call the back end. So we're gonna put so we're extending the tool to automatically extract this data as well. So the graph will be much larger, and we will be able to identify design issues in testing, and also for regression testing that we use. Again, hopefully that feature will be available in the next few months, and I will record more videos of that as well. So again, as I said, this is the first video of our cool tool, GaugeDepend. I hope other test engineers will find this useful and will use them in their projects. All the best.